Section 1.4, trigonometric functions of any angle. Section 4 is going to kind of tie a ribbon on like these first four sections, you know, or it kind of builds on the first three sections and kind of wraps a lot of things up, and a lot of things come full circle, you know, no pun intended. And these first four sections together make a nice little package, okay? Before we are, you know, before we change gears in the next section. So in section 1.5, we're going to kind of change gears a little bit, whereas this section really follows suit from section 1, 2, and 3. So let's start. Trig functions of any angle as long as you got the coordinates of a point. Okay, sorry. So the first example says let P equal -3, -5. So there's a point P with these coordinates, and it's a point on the terminal side of theta. So in other words, this point corresponds with this angle, you know. It's a point for that angle. Find each of the 6 trig functions of theta. So sine of theta, cosine of theta, etc. Now I think the significance of this example is that in the past you might have assumed that if, you know, you're given x and y essentially, okay? So what is x? I mean, sort of a spoiler there a second ago. They gave it to you for free. So they're giving you a couple things for free. So what's x? -3. They also gave us the y value for free, -5. And like I was saying, in the past, you know, you might have been given an example where if you were given x and y, that it would have been a point on the unit circle, which would have meant r equals what? R would equal 1 if this was a point on the unit circle. But in this section now, this example, this point, is it on the unit circle? No, not necessarily. So the r value is not necessarily 1, and I can pretty much tell you that it is not going to be 1. So this is a point that is not on the unit circle. But, I mean, we still need r, right? If we're going to identify sine of theta, you know, it's going to be y over r. So we need r. We have y, we need r. So maybe at this point by now, after going through all these, you know, section 1, 2, and 3, and now we're on section 4, if you are given x and y, how do we find r? The answer is the Pythagorean theorem, of course. That makes sense. And so as we let the formula play out here, I just want to remind you that when you are plugging in something negative for x and also y, you know, we're plugging in -3 for x and we're doing -3 squared. We're squaring the entire x, so we're not just squaring 3, we're squaring the negative along with it. So -3 squared is what? +9. I just wanted to make a big deal about that for a second. And so -5 quantity in a way squared is 25, +25 that is. And so with that being said, we can let the formula finish out. And just a quick reminder again, sorry. What do we do at the end of the formula to figure out what r is? We take the square root of both sides. And since for some reason I feel in no rush right now today, I'll just kind of write it in. And And so we get the radius as the square root of 34. Now, did I make a mistake and not finish this up by simplifying? Can the square root of 34 be simplified? Because you should always simplify square roots if possible, right? Can it? Did I screw this up? Of course not. Root 34 cannot be simplified, and so that is r. And sorry, and now that we know x, y, and r, it's Christmas, right? Identifying the sign is easy since we know the sign is y over r. And so it's that. And cosine's what in terms of x, y, and r? What is the cosine? It's x over r. And the tangent is y over x. Hopefully you know by now. And you should obviously be, jumping all over the fact that a negative divided by a negative is overall, as a final answer, positive 5/3. And hopefully at this point in time, look, again, like it's section 4, it's building on all this other stuff from before. At this point, I hope you're very comfortable. I don't need to hold your hand through it. Once you have sine, cosine, and tangent, the cotangent is just the flip of the tangent. The secant is the flip of what? Cosine. And the cosecant is the flip of the sine. So I think on your own you can write out the rest of that. Next example. You remember in the past, like I think I said this 2 or 3 times at least, there's these 4 angles that if I wanted to do the sine of an angle or the tangent of an angle or whatever, the 4 quote-unquote easiest angles are 0, 90, 180, and 270. Because the coordinates on the unit circle for those angles are ridiculously simple and easy to come up with, right? At the drop of a hat, But let's officially label them with a fancy vocabulary word, the quadrantal angles. Let's finally give them the official name, okay? Not the biggest, battle that we need to fight, I guess in other words, I'm not going to quiz you on, the vocabulary word quadrantal. Just throwing it out there for you. Obviously more important to be able to execute problems like what is the cosine of pi? And this is not even a new example. We've done this in at least one earlier section, maybe even a couple earlier sections. We did this exact same sort of problem. And cosine of pi, well, we like degrees better, don't we? How many degrees is pi radians? Pi is how many degrees? You better know that it's 180. And like I said a minute ago, this is a very easy angle because the coordinates on the unit circle are very easy, very simple. What are the coordinates for this point on the unit circle at 180? Negative 1, 0, which means x is that, y is that, and since we are on the unit circle with this point, r is 1, you should know. And cosine, you should know, is defined as what? In terms of x, y, and r, what is it? What's the definition? X over r, and so bam, bam. Okay, again, that example was not new, not even close to being a new example. We've done it before. Let's move on to something new, I guess, a new concept in section 4. The signs of the trig functions depending on the quadrant. And we've probably pointed this out before that this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Roman numerals are something. Get this in bounds a little bit more. Anyway, let's get to the point. Question, Dwight Schrute style. In what quadrants is the sine of the angle positive, right? So, what quadrant or quadrants contain angles that if you took the sine of those angles, you would get just some positive answer. So where is the sine of the angles positive? Little pause. Hopefully you thought that it was quadrants 1 and 2. And quick reason why? Well, I mean, what's the definition of sine? You know, it's the y-coordinate divided by a radius that's always positive. So since the sine is like all about y, isn't the y-coordinates always positive, or the y-coordinates always positive in these two quadrants? Look, this is like the positive y-axis, right? So definitely these two quadrants. Now, contrary, or struggling with the word here, but coincidentally or whatever, or where the sign is negative, is quadrants 3 and quadrant 4, of course, because this is where you'd have negative y-coordinates. This is the negative y-axis. Now on to cosine. In what quadrants or quadrants is the cosine positive? Cosine positive. Well, the cosine is all about x. It's x over r. And where is the positive x-axis? It's here. And so the quadrants are 1 and 4. And so therefore, 2 and 3, where you'd have negative x coordinates, that's where the cosine of these angles would be negative. So just a quick, to interject a quick example to help you understand. If I asked you, what's the cosine of 175 degrees? Like 175 degrees is about right here, you know? It's in quadrant 2. So what's the cosine of 175? You could say, well, I mean, I don't know, but I can at least tell you the answer is going to be negative, you know? The cosine of 175 degrees is negative something. Just like you could say that the cosine of 325 degrees is positive something, you know, because I know what quadrant 325 degrees is in. Anyway, moving on to the tangent. In what quadrants is the tangent positive? The tangent, remember, better know this by now, it's y over x. It's the y-coordinate divided by the x-coordinate. So in what quadrants is the tangent of the angles positive? Little pause. Did you guess 1 and 3? Quadrant 1, because it'd be like a positive y divided by a positive x. And quadrant 3, because it'd be a negative y divided by a negative x. And a negative divided by negative is positive. And so therefore, conversely, maybe the word I was trying to think of earlier, where's the tangent negative? Quadrants 2 and quadrant 4. Now down here, just to wrap up this page, a little memory trick. If you, maybe you'll just remember these because of, why it is what it is. Positive y-axis, negative y-axis, blah, blah, blah. But, if you want to just remember, just plain remember, there's a memory trick, and a very common one that goes like this. And starting at quadrant 1 and going to quadrant 4, little saying, all students take calculus. Or I recently heard a different one. I just can't think of it right now. Maybe I'll think of it like actually in class, and you can ask me in class or something. But for right now in this video, I'm going to go with all students take calculus. Hopefully that's easy to remember. All students take calculus, right? Or at least it'd be pretty cool if they did, if all students ended up taking calculus by the time high school was over, or maybe college was over. But that's how you remember. But what these letters really stand for, as far as the math goes, is this does stand for all. This stands for sine. This stands for tangent. And this, of course, stands for cosine. And what it means is, in this quadrant, all of them are positive. Sine, cosine, and tangent. So just to kind of make my point here, they're all positive in this quadrant. In this quadrant, the sine is also positive. In this quadrant, the tangent is also positive. And in this quadrant, the cosine is also positive. So cosine, cosine, sine, sine, tangent, tangent. That is where they are positive. Okay, moving on. Next example. So building from that, if the sine of theta is less than 0, that means negative. Well, oops, I thought maybe well, whatever. I thought maybe behind that box said it means sine of theta is, well, because it does. When they say sine of theta is less than 0, they mean that if the sine of theta is negative. So in other words, negative. And sine of theta is negative, less than 0, in these two quadrants. And the cosine of theta is less than 0, in other words, negative, in which two quadrants? Those two. So if we have both of these, if the sine of theta is negative and the what quadrant would theta have to be in for both the sine and the cosine of that angle to be negative? Well, which do they have in common here? Quadrant 3. All right. Sorry, that was kind of a little bit of anticlimactic example there. But next example. So, a little more advanced, complicated problem. Given that the tangent of theta is negative 1/3, and the cosine of theta is negative, basically, less than 0, I want you to find the sine of theta, what the sine of theta equals, and what the cosecant of theta equals. Well, here's one of my immediate thoughts. I don't know if you share that immediate thought. Finding the cosecant is just going to be a matter of flipping the sign. Whatever I end up getting for sine, I'm just going to flip it to get the cosecant. Anyway, well, we got to get the sine. So what do we need? What do we need to figure out the sine? We need y, and we need r. Get a quick sip of water. So what do we have? Tangent, what are they telling us here? This is obviously y, but is it negative or not? So y is 1, or maybe it's negative 1. X is 3, maybe it's negative 3. I mean, I don't know which one's negative right now. I mean, I hope you understand when I say they can't both be negative. All right? If the 1 was negative and the 3 was also negative, wouldn't the overall fraction be positive 1/3? Because a negative divided by a negative would have been positive. So they're not both negative. It's one or the other. It's the 1 or the 3. I just don't know which one it is yet. But I do know that the overall tangent is negative. But they also make it a point to tell me this. Now the cosine's negative in 2 or 3. So at this point I got to put these together. In which quadrant is the tangent negative? Or, I mean, you could think of it that way. The tangent would be negative in 2 or 4. Okay? So maybe the bottom line. The bottom line is that we are in quadrant 2. Okay? However you want to get to like the bottom line, your own little bottom line about basically how x has got to be the negative one, okay? I mean, maybe like me, you can like just look at this. Oh, if the cosine's negative, that means x has to be negative. Cosine is all about x. So if you tell me the cosine's negative, x is negative, you know? And if, well, I won't really go there, but into hypotheticals, but so cosine's negative, that means your x is negative. It means you're in quadrant 2 because of this and this. And so the bottom, to finish off this bottom line, it must mean that the 3 is the negative one. So it's negative 3, and that means y is positive 1. So, well, now what do we do? I mean, we're not done, right? What do we have to do now? I mean, we're in a much better position to find sine, right? Because now we know that y is positive 1 and x is negative 3 just from all the clues, all the evidence. Sine is y over r. Do we have r? No, but we can get it pretty quick here. By doing the Pythagorean theorem, of course. And of course, if 10 equals r squared, then we take the square root of both sides. Can we simplify the square root of 10? No. So that's my answer for the radius. And so therefore, my sine is going to be y over r, which means my cosecant is the flip of that, root 10 over 1, which you should just write as root 10. Next. Okay. Moving into the next sort of section of this lesson, I'm going to now teach you about reference angles. Okay? So there's more special angles out there than just 0, 90, 180, 270, and these three. We've worked with them before, back when we knew all the unit circle coordinates, or we had access to all those coordinates. But anyway, let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle, theta prime. Sorry for being all this fancy lingo. But the reference angle is basically the angle that's formed by the terminal side of theta, these purple lines, as you should know, and the x-axis, or like the nearest x-axis. So even better by picture, okay, if this is theta, because we're over here in quadrant 2, then this is theta prime. And I'm not even going to write it because it's just not necessary. I mean, really, I'm not going to require that you use that specific label and notation and stuff like that. But because here's the bottom line. It's the angle formed from like the nearest x-axis. The nearest x-axis, not the y-axis. The nearest x-axis. So if this is theta, or essentially if we're over in quadrant 3 for some angle, then the reference angle is that. That's the reference angle. And if we're over here for theta and being in quadrant 4, then the reference angle is right there. It's the angle formed with the nearest x-axis. Okay? Usually it's better by picture, isn't it, than all these fancy words. So find the reference angle for each of the following angles. So just kind of quick, you know, I think we got bigger fish to fry than just little baby examples like this. But so 315 is right there. And so the reference angle would be right there. Yeah? So what is the measure of this angle? How big is this angle? If this is 315, if all the way to here is 315, wouldn't it be like the rest of the degrees that it would take to get to 360, you know? And wouldn't you just then subtract, you know, 360 minus 315? So the bottom line is, the answer is 45 degrees, isn't it? You know? And that's just kind of how it's done. So 5 pi over 6. Let me grab my handy dandy calculator. How do we change 5 pi over 6 into degrees? We just plug in 180 for pi. That's not new. 5 times 180 divided by 6. I'm getting 150. And so drawing a picture helps. 150 should be about, yeah. And so that would be where the reference angle is. And so what would that be? If from here to here is 150, wouldn't it be the rest of the way to 180? With this being 180? And so kind of similar to number 1, I know we skipped number 2, I guess, sorry for going out of order technically. Wouldn't this be 30? To get to, you know, the rest of the way to 180? 8 pi over 6. 8 times 180 divided by 6 is 240. 8 pi over 6 should be 240. And so 240 is like right there-ish, you know, and so this is where the reference angle would be, you know, again, it's formed to the nearest x-axis, okay? I know 240 is a lot closer to this y-axis, but we always form, not to be a broken record here, but always to the nearest x-axis. So if from here to here is 240, then what's that? I mean, how far past 180 did we go? Wouldn't this be 60 degrees? Because in order we'd go 60 degrees more than 180 to get to 240. See a little subtraction, okay? 410. Well, that would be going all the way around 360, and then wouldn't we have to keep going another 50 degrees to get to here? Which, if that's the reference angle, I just kind of answered my own question there almost immediately. Looks like the reference angle for 410 would be 50. And now on to some bigger fish to fry, okay? First of all, 7 pi over 6 in degrees is the tangent of 210. All right? Now, you know, to give you some perspective, if we wanted to find the tangent of 210 degrees, obviously we could use a calculator, but, you know, sorry, no. Or what Mr. Birchanowski does, I've mentioned this in the past, I've mentioned this recently, that you could use the unit circle coordinates for that angle 210, you know. It's not hard to look them up, okay? there are coordinates for this angle on the unit circle. And then you can just do y divided by x, using those coordinates. And that's actually what Mr. Birchanowski does. He has a nice way for his students to memorize all those coordinates, okay? I have a slightly different, again, I always say it's a horse apiece. What you memorize for him versus memorizing with me. So here's what I do, okay? Because you will not have access to those unit circle coordinates, okay, on the test. Here's what you need to do. You need to go in the plane, okay, and draw the angle for 210. So where is 210? 210 is like right there, okay? And now what you're going to do next is draw a triangle to the nearest x-axis, just like with these reference angles, because the reference angle is going to be very, very, very important. So what is this reference angle for 210? What is this angle? Wouldn't it be 30 degrees? Huh. 30 degrees seems very, very nice, doesn't it? So now think about this entire triangle here. Doesn't that make this a 30, 60, 90 triangle? So again, I've said this you need to have by now like these side ratios memorized. So the next step is labeling the sides of this special triangle the way you should know it works with a 30, 60, 90 special triangle. So you should know 1, 2, square root of 3. The 1 is across from the 30. That's how it works. The root 3 is the leg across from the 60-degree angle, and the hypotenuse is 2. Okay? But look, aren't we kind of going in the negative x direction? Like, isn't this the negative x-axis? So negative root 3. And isn't this the negative y-axis right here? We're pretty much going in like the negative y direction. So I'm going to actually label that as negative 1. Okay? Because, see, now I'm actually ready to do the tangent, but not so much maybe with y over x, even though you could. I'm going to do SOHCAHTOA. So what was the SOHCAHTOA definition of tangent? SOHCAHTOA, so that would be opposite over adjacent. TOA. And we're going to use the reference angle. And what was the side opposite of the reference angle? 30. That would be negative 1. And the adjacent leg is negative root 3, which, you know, any cleanup to do? Well, negative divided by negative is just going to be overall positive. Okay? So, again, I want to re-emphasize or reiterate on how I made this a negative root 3 and a negative 1, okay? Because, look, in a way, we were doing the tangent of 30, weren't we? Right? So this is going to be a reoccurring message and theme going forward. Doing the tangent of 210 is very, very similar to doing the tangent of its reference angle 30. Okay? The only difference can be, or potentially is, that 30 degrees is like a quadrant 1 angle. 210 is in quadrant 3, where the tangent is potentially negative or positive. In this case, its tangent's positive in quadrant 3. And so, at the end of the day, I guess the bottom line here is that your final answer needs to be correctly positive or correctly negative, depending on the situation. In this case, your final answer needed to be positive because tangent of 210 being in quadrant 3 needed to be positive. So let's remember that going forward. Tangent of 135. Once again, there's 135. We draw a triangle to the nearest x-axis. And next we think about the reference angle. So what would be the reference angle right here if this was 135? It'd be 45, which is going to make another special right triangle. And now you must label them. Okay? Now again, at the end of the day, I guess when you end up doing the tangent of 135, you're going to remember that this is quadrant 2, and tangent is negative in quadrant 2. So as long as your final answer, you make sure it's negative, then you're good. Or you can just go, well, this is a negative x direction. This is what? Is it a positive y direction or a negative y direction? It's positive. So I'm going to leave this positive, and of course the hypotenuse slash radius is never negative, like I've said before. So now we can do SOHCAHTOA again. And it's tangent again, so it's opposite over adjacent. So opposite of 45 degrees is 1. Adjacent would be -1, and we can simplify that to just being -1. Again, as long as you make sure that your final answer is what it's supposed to be, positive or negative, then you don't really need to label the sides negative or positive. But this is how I was groomed and brought up, and when I was your age, this was my process. But let's do some more examples. At this point, feel free to try these on your own before I run through them. Pause the video and stuff. So this should be 300 in degrees. 5 pi over 3 should be 300, which is right there. And so the reference angle here should be 60. Another special triangle, yay! And now we got to label it. So if that's 30, then that's where 1 would be. The hypotenuse is 2, and see, you have to know these ratios, the 1, 2, √3 thing. Now, are any of these negative? I mean, I'm not going to make the 2 negative. No way. Should I make the 1 negative? No. Should I make the √3 negative? Yes. So cosine, now I'm ready to do SOHCAHTOA. So that's adjacent over hypotenuse according to SOHCAHTOA. And when what's adjacent to the reference angle, that should be 1, and the hypotenuse is 2. Positive 1/2. Final answer. Okay? Now, again, just kind of double checking, I guess, another way. Does it make sense that my final answer ended up being positive? Again, doing the cosine of 300 is just like doing the cosine of 60, but, I mean, we're in quadrant 4, Is the cosine positive in quadrant 4? Yeah. So this being positive 1/2 makes total sense. And one more quick follow-up comment. It turns out that doing the cosine of 300 is not just similar to doing the cosine of 60. It's exactly like doing the cosine of 60. The cosine of 300 is exactly equal to doing the cosine of 60. Sine of -315. Ooh, a negative angle. Do you remember those? That would be -315 wouldn't that be here? And so drawing that triangle, what would be, that should be 45. Yeah, so 1, 1, square root of 2. Do I make either of these negative? No, we're in quadrant 1. Sine, according to SOHCAHTOA, is what? So opposite over hypotenuse. So opposite the reference angle would be 1. Hypotenuse would be root 2. And yes. Some follow-up examples. New for 2018. The fall of 2018. What's left here? Oh yeah. Now these can be, I'm going to refer you back to this example, quick, where they told you, or I told you, that the tangent was this and the cosine was negative, and from here we had to figure out that that this, little lisp there, sorry, that this was y over r. It turned out that y was positive 1, but that x was negative 3, and we could kind of go on from there. So, look at this. If they tell you that the cosine is negative 3/7, yeah? What does that mean? Isn't the cosine x over r? So, do we need to figure out which one's negative? No. In this case, so the reason we're doing this example specifically is we already know that x is going to be, it has to be, negative 3. And r is positive 7, because I've said it a dozen times. R is always going to be positive, okay? Just by nature, just by definition, okay? So we already know that x is negative 3 and r is positive 7. So now we can start finding y. Make sure you play the Pythagorean theorem game properly and plug in 7 over here. So 9, positive 9. Gosh darn it. So y squared is going to equal 40. Let me just double check on all this. X squared plus y squared equals 9 squared. 9, yeah. Okay. So that means y is the square root of 40. Can the square root of 40 be simplified? Well, yeah. Oh, and I might as well do this now. Okay. Because this is easy to forget, okay? You got to figure out a way to not forget this part, because I think it's easy to forget. I mean, I didn't technically forget, but I was going to do this a step later, but I'll do it now. When you are solving for y, and I mean, when you're solving this equation in general, okay, like just in a vacuum, you don't just get one answer of root 40, you get plus or minus root 40. So, why don't I, maybe you'll have a, why is this undo, there we go. So maybe you'll have an easier job erasing or squeezing that in. Technically, it's plus or minus root 40, because look, here's the thing in this example, the big challenge. When we solve for y, you have to make sure you're getting the sign of it correct. Yeah? Let's figure that out in a second. First, can the square root of 40 be simplified? Heck yeah, isn't it? Isn't the square root of 40 root 4 times root 10, And we can do that as just 2. So plus or minus, now we can do the plus or minus part. How do we know whether y is supposed to be positive or negative? Well, we got to go to the other piece of evidence, okay? If the cosine's negative and the tangent is also negative, what quadrant does that put us in? You know, what does that tell us about what y needs to be, positive or negative? Cosine's negative, you know, and I don't know if maybe just at least one time we'll do a picture like this. Cosine is negative here. Like that's where the cosine's negative. Where is the tangent negative? Wouldn't it be there? So we put those together, we pretty much, this angle theta has to be in quadrant 2. So y is going to be positive 2 root 10, won't it? It should be. And so now we can find sine and cotangent really, really easily. Again, that was the big hump to get over, you know. So to quick recap here. Okay. When you were given this, considering that it was x over r, figuring out that this was negative 3 and this was positive 7, wasn't that difficult, okay? But when you went off to find y, you know, you had to, here, that was bothering me, sorry. When you went off to find y, you had to remember that for your final answer, you needed to assign the right positive or negative sign. Which this is supposed to help you do that, figure out what quadrant you're in, and therefore y being positive. See, after all that, sine being y over r and all, and so therefore positive 2 root 10 over, what was r? 7. And cotangent would be the flip of tangent, and so x over y, correct? And so my x was negative 3 and my y was that. And so that's how that example finishes up. One more example. Okay? Maybe the trixiest one overall in this category, you know. Tangent being y over x. Oh, so y is positive root 21 and x is positive 2, right? Guess what? Not necessarily. It's possible that this is negative and that is also negative, because it could have been a positive this over a positive that, or it could have been a negative this over a negative that. They both result in an overall positive tangent. Looking at it from another angle, no pun intended, in what quadrant is the tangent positive and the sine negative? Let's do this little picture game one more time. Where is the tangent positive? There, right? Quadrant 1 and quadrant 3. Where is the sine negative? Looks like we're dealing with quadrant 3. Well, guess what that means? That means that x is negative and y is negative. So we have x being negative 2, actually. Plot twist there. And y is negative root 21. Well, now what do we need to do? I mean, especially considering what we got to find, you know, we need r. So once again, The next step is to bust out the old Pythagorean theorem. So negative 2 and positive 4. What's this squared, huh? 21. Root 21 times root 21 just gets me 21. Or root 21 squared is just 21. Including the negative, it's still going to be positive. Ooh, this is turning out nice. So again, technically speaking, if this was just an equation all by itself with no context, you would get plus or minus 5 equals r, when you take the square root of both sides. But it's r, it's the radius, so we obviously know this is going to be positive 5. And now we know x, y, and r. We have everything we need to know. So the cosine is what? Defined as x over r. We know x and we know r now. So x is negative 2, r is 5, and awesome. And so now we can do the cosecant, which is the flip of sine. And that is the flip of sine. The radius is 5. The y value is negative root 21. And we are done.